So today we're going to be going over 5 tests that you can do on your soil to learn a bit more about it and make sure your plants have everything they need. The first test we're going to be looking at, we just need a bit of stick or a screwdriver, just something round, firm and straight. What we're going to be doing is coming to our soil and just going to be pushing down to see how easily and how far it goes down. So we're just going to put a nice bit of pressure, and as you can see, this goes all the way through really nice and easily. This is a piece of ground that I just recently turned and de-weeded, so it should be nice, loose and compact. So this is my strawberry patch that I'm going to be revamping shortly. We're going to come in here and do the same. So we're going to push, and as you can see, it kind of gets stuck. There's a bit more compaction. It still goes in a good 3-4 inches, which is really great. So that test is for compaction. Compaction is going to tell us about how the roots are able to develop, if there's enough oxygen in the soil. When there aren't enough spaces, oxygen can't get in, microbes can't produce properly, and then we start having issues. So we want to make sure it's nice and loose. If you are compacted, turning it, digging it can be a good call, but a lot of people don't like to dig the soil because you're breaking up the structure. So I personally would be considering adding maybe sand or compost to add organic matter. This will break up those clayey, tight, small clumps of soil and allow things to permeate much more into the soil. For the next test, what we're going to be looking at is soil permeability. So how quickly does water absorb into the soil? This is really important because we want to trap rain in the soil. If it pools on tops and runs off, obviously that can take the topsoil with it. So having a nice soil that can allow water through keeps it moist, keeps the soil and the roots happy, but it also makes sure that we don't get any runoff. So I've got myself a tin can, just taking the top and the bottom off. I'm going to pop it on to the soil, push a little bit to make sure nothing runs out in the gaps at the bottom and that it's flush with the soil. Next, we're going to take a little bit of water and we're just going to gently pour about an inch in, and we're just going to count how long it goes. So as you can see, this goes really very quickly. That's a great sign that the soil has lots of airspace, that the water can go in and we're not going to be having any runoff. So next, I'm going to be comparing this to the grass path. So again, just pour about an inch of water. And as you can see, it's taking much longer for the grass path to absorb that water. Part of the problem with the grass path is we're constantly walking on it, which compacts it. We have a lot more roots and organic kind of firm matter that makes it harder to permeate in as well. This can be improved by not walking on it and having more organic matter in the soil. This isn't a priority because this is just the path going up and down between the allotments. But if this was your lawn, for example, or even a field where you're grazing and trying to grow grass for grazing, this would be a really important check that you'd want to improve, so that if you did have a big rainstorm, for example, that it didn't just flood and cause issues. So with that absorption test, we can kind of roughly work out how long it's going to take for an inch of rain then to absorb into the soil, and it gives a good idea of how heavy a rain our soil can take. So a nice small bit of rain, most soils can take that, but when we start to have these big rainstorms, it can just give us a good indication of whether we're likely to have flooding or runoff or just taking topsoil with it. So the better the absorption, the less damage it's likely to take, and the better water retention you have. So this is about 5 minutes later and we still have a good ½ inch in there. It just shows you how slowly water can go into the soil, particularly when it's been raining. We've had a lot of wet weather here in the UK, so the soil is quite waterlogged already, but it just is taking a very long time. What we're going to be checking next is the makeup of the soil. Soil is made up of sand, silt and clay. These are the 3 main structural parts to it. There's obviously lots of other different pieces and organic material in there, but those are the 3 main parts that we can check for in our gardens. What we're going to need for this is a container with some water, and we're going to add a good amount of soil into that. What we're going to do next is give it a good shake, get the soil fully mixed up, and then just leave it for about 6 to 12 hours to settle, and then we will be able to gauge the different levels and the different amounts of each of those in the soil. So what I'm doing is just taking a bit of soil, popping it in the water, and then we can pop the lid on, lock it up, and give it a good shake. And what we'll do there is dissolve as much as we can, separate the different pieces into the components, and when it settles, we'll be able to have a really clear view of what it is made up of.
Here is the result. So there are three distinct lines in which obviously the top being the clay, the middle being the silt, and the bottom being the sand. Surprisingly, there's actually quite a lot of sand in my soil. That's why you do the test, because it's not always clear from what you're doing. As I turn, you can see the layers much more distinctly. What isn't there much is the silt. So there's a dark bit at the bottom. This means I'm going to have to spend a lot of time adding in compost and extra organic material to build this up. There might be lots of sand because often people use sand to try and break up the clay, but this doesn't work unless you have the silt. So you want to make sure you're having about equal ratios. So don't add sand just to clay. You need to also add the organic material, else it will just stay really clayey.
For the next test, what I'm going to be looking at and using is a pH meter. So one of these, they're really cheap. This one was about £15. It's understanding our pH is really important for keeping plants happy. Certain plants like certain pHs, we want most often just slightly acidic soil. That's where you're going to have most plants being happy, but different plants, different things. Blueberries famously really like acidic soil, which most other plants aren't going to be too happy with. So you want it around neutral, maybe just in slightly acidic, that most plants then are going to be able to tolerate. This just gives us a nice reading. We pop it into the soil and just let it register. So once it's settled about 6.6. It's going up and down a little bit. As we go a little bit deeper, it does change, and it seems to get a bit lower as we go deeper down, which is quite interesting. I'm unsure exactly why that's the case. I'm going to try over here as well. With all these tests, it is important to check lots of different areas. So again, 5%, 5, which is quite low actually. So here we've got about 6.2, which is slightly further up. It keeps going down, so it seems like I have slightly acidic soil, which is surprising because it's quite clayey.
Clay soils are often more alkaline, so this is quite surprising and a really important reason why you should test them.
This also gives the soil temperature and moisture content as well. So when we pop it in, it will tell us roughly how warm the temperature is. This again is really important for planting certain crops out. They like the soil temperature to be at a certain level before they start to grow. We can see that the soil is very wet, which makes sense as we've had lots of rain, and it also gives us a reading on the light levels, which is obviously very high because I'm outside, but this can also be used for indoor plants and give you a good idea there.
This is my compost heap, and as you can see, the compost is less acidic, which would make sense as it has much more organic
final
material.
test that's probably the easiest of the lot is to take a handful, and when you squeeze it, see what happens to it. Mine's got a few rocks in it. Let's get rid of those. Let's squeeze it and see what happens. This one bowls up into a clay, and when we kind of push it slightly, it kind of breaks. This is indicating that it is quite clay. It's got a stickiness to it. If we hold it, it just keeps its shape. We can roll it. So there's quite a high clay content. If this was loamy, it would crumble a little bit more as we put the pressure on it. And if it was sand, obviously it would just fall apart. So another really nice easy test, just to get a rough idea wherever you go, just really quickly by just feeling it. You can also feel and rub it through your fingers. And you often, when you do this, if you're feeling nice and soft and fine. That's the clay particles. The silt will feel a little bit more grainy, where sand obviously is very coarse. So just using your hands, you can get a lot of information about the soil.